Hello and welcome. In our last topic, we built systematic process for troubleshooting application, our pod and services. But what happens when the problem is bigger? What if pods are stuck in pending and never get scheduled? Or what if a whole section of your application suddenly goes offline? This often means that the failure isn't the application, but with the cluster infrastructure itself. There are many factors that can render Kubernetes cluster faulty at the component level. Just like application debugging, we need a calm, systematic approach. We will start with the 1000-foot view and then drill down into the two main areas of failure, the control plane and the worker node. Part 1. Cluster Health Check. Your very first command when you suspect a cluster level problem is always kubectl get nodes. This is your main health dashboard for entire cluster. So right now I'm using kubectl get nodes. As you can see, both nodes are in ready state. So this output gives you immediate lay on the LAN. You can see the roles for each node, its age and the version. You're immediately looking for two red flags. Is the status anything other than ready? If you see not ready or unknown, that node is sick. The control plane cannot communicate with kubelet and will not schedule new workload there. Does the version deviate? Having mismatched Kubernetes versions between your control plane and your worker node, or even between different workers, can cause strange, unpredictable behavior. If your nodes are ready, your problem is likely not to core infrastructure, and you should go back to the troubleshooting application. But what if your control plane node is not ready? Or what if your commands are failing entirely? Part 2. Troubleshooting the control plane. So the control plane is the brain of your cluster. If it's faulty, the entire cluster is compromised. Detecting a problem here should be treated with extreme urgency. The first step is to check basic connectivity. Your first check is to see if the API server is even responding. So I'm using kubectl cluster info. If this command fail or timeout, your API server is likely down. If it succeeds, it gives you the address, the control plane, and confirm that the kubedns core DNS is registered. For massive data dump of your old cluster state and log, which can be pages and pages long, you can use kubectl cluster info dump. This is last resort, but it can be useful for offline analysis. With kubectl cluster info dump, as you can see, we have lots of pages about the whole cluster. Basically, this is very useful when you're using like LLMs like ChatGPT or Gemini or any kind of AI tool. Step 2. Inspect the control plane components. So this is the most important step. The control plane is not one single program. It's a collection of specialized microservices. On kubeadm cluster, these components run as static pods in the kube system namespace. Let's list them. So I'm using kubectl get pods-n kube system. These are just crown jewels of your cluster. etcd. This is your cluster database. If etcd is not running, your cluster is dead. Kube API server. This is front door, the REST API that kubectl and other components talk to. Kube scheduler. This is the air traffic controller that decide which node on which pod should run. Kube controller manager. This is the thermostat that's run all reconciliation loops, making sure your cluster actual state matches your desired state. If any of these are not in running state or have high restart count, you have found a critical problem. Step 3. Check the components log. Since these are just pods, we can use the same troubleshooting tools we learned for application. If your kube scheduler is crash looping, check its log. So I'm using this kubectl logs-f kube scheduler. Reading the logs for these components will almost always tell you what's wrong. Perhaps a misconfigured flag, a bad certificate, or inability to connect to the etcd. Part 3. Troubleshooting the worker nodes. This is the most common infrastructure failure you encountered. A worker node suddenly reports not ready. So let's get the report of the nodes. Both nodes are in ready state. A not ready status means that the kubelet process on worker 1 has stopped sending its heartbeat to the control plane. The control plane assumes the node is dead and will not schedule it any new paths there. Our job is to find why. Step 1. Checking the node condition. Your first step is to describe the broken node from your control plane. So at the moment, I don't have any broken node, but I can show you this worker node, and we can scroll up to the condition. Scroll down to the condition section. This is the kubelet last will and testman. In this last status, it's reported before it went offline, for example, for our node. But in this case, our node is online and ready. But if your node is broken, this is the first place to check why. Look for any condition that's true. Expect for ready. Step 2. SSH onto your node. Now we must SSH directly into the node to confirm. So I can connect to the 201, which is the worker node. And once you're in the node, we can use standard Linux tools like df-h for checking the current disk usage. So it's 59% of the disk. If it's more than 18 or 90% of the disk usage, I'll get the disk pressure on the node, and it will immediately evacuate the pods from my nodes if there is any other worker nodes in the cluster. Let's use freem. So if we suspect the memory pressure, we can use freem or top. These commands will confirm that the node is like out of resources or it has enough resources for processes. Then the next step is to checking the kubelet processes. If resources look fine, then most likely the culprit is the kubelet process itself. The kubelet is the main Kubernetes agent on the node. It's a system service, not a pod. We check it with the systemd. So let's use system status, systemctl status kubelet. As you can see, it's active and it's in running state. So the most important line is active. If it says failed or inactive, the kubelet has crashed. To find out why, we can use the journaling system. So I'm using journal.ctl, and then I'm using -u for the unit because the unit name is kubelet, but I'm using extending flags like -xe and then u. As you can see right now, I don't have any ongoing issues because I used the -f flag. But here I had some errors syncing pod, skipping something. So these are just some errors that are not exist anymore. You would scroll through these logs to find the error. A very common error is expired certificate. The kubelet uses a TLS certificate to talk to API server. If that expired, the API server will reject it and the node will go not ready. You can check your kubelet certificate validity with OpenSSL command. So let me check the certificate validity. As you can see, I use OpenSSL X509 and then I read this certificate and then I'm checking the validity. It's valid until 2026. So if the date is in the past, you found your problem. Once you have fixed the underlying issues like freeing up the disk space or renewing the cert, you restart the kubelet service. The command is systemctl restart kubelet, and this will restart your kubelet service. Then go back to your control plane and then kubectl get nodes and watch. So you should see that the status fill up the not ready back to the ready. So we can back to the control plane node. SSH to back to the control plane node, and I'm watching the nodes. So both are in ready state as expected. So step 4 is checking the kube-proxy pod. If your kubelet is fine, one of the most component to check on the worker node is kube-proxy. This is the component that manage all the network rules like IP tables or IPVS that make the services work. So kube-proxy run as a pod on every node, managed by a daemon set in the kube system namespace. So if I use this again, we can see that we have kube-proxy running on our node, like here in the controller and in worker node. Using the -o white flag, we can find the exact kube-proxy pod that's running on our broken worker one. If that pod is crashing or in not ready state, which is not in our case, we can treat it just like any other pod. So we can use kubectl logs to see the actual logs on this pod. So let's see what is the current log on worker node. So the caches are saying everything looks fine. That's because the cluster is ready. If we had some major issues, we should have some sort of errors in the log here. A failing kube-proxy will often cause networking failure for all pods on that specific node if the node itself appears ready. Summary: your troubleshooting flow. As you can see, troubleshooting the cluster itself is just a matter of flowing a calm, logical flow. Start with a kubectl get nodes. This tells you if you have a node problem and where it is. If the control plane is the problem, investigate the component pods in the kube system namespace. Check their status and their logs. If the worker is a problem, start with kubectl describe node to check if the condition. Then SSH into the broken node, use Linux tools like df and top to check the resources, and systemctl and journalctl to check the kubelet services. Finally, check the kube-proxy pod for that specific node. The systematic process removes a panic and gives you a clear checklist to find the root cause for any failure cluster. This concludes our lesson on troubleshooting. Thank you for watching.